Okay guys, I've changed the light a bit. Okay, I'll be solving another question here. I found it quite interesting. Uh, in a first glance, it looks easy, but while I was thinking how to solve it, I had a very different opinion because yes, we can just square it out. We can solve it in n log n very easily. We can just square it out and use the sort function. But I was just thinking if we can solve it in n O of n time complexity. So for that, the top of my mind that came was maybe we can just segregate two different lists, one with values less than 0 and one it from 0 to the one higher, and then we can merge them. How to merge them, let's think on it later, or because I think that won't be the tough task. So we'll have to do three things here, or three things. Yes, one is we have to find this index. This index. Before that, I think we should just uh, if no negative, just return the squares. And the second will be to find first greater or equal to 0. And 3 merge, and then sorry, 4 steps will be square and return. Okay, so for the first step what we can do is that if no negative, just return the squares. So for I in nums, no, if I nums of 0 is greater than or equal to 0, return x for x in nums, right? This will be n of n because we are looping here once. So this is done. Second will be to find the index of first. For I in length nums, if nums of I is, suppose it's greater or equal to 0, then we'll just get the I. So I'll just write a variable here, equals to I, right? This will also be of n. Merge them. Alright guys, light is off, charge went out, so Still, let's finish it off. Okay, so we have to merge them. So to merge them, I'll say first segregate it out. Say positive, negative, positive. We'll have two different arrays. Okay. So how to get them? Do slicing work here? If it was a numpy array, we can just but it's not numpy array. So let me check one thing. Okay, we can do it here. So here what we'll do is that nums of till idx, so it's inclusive, 2 3, this is inclusive, and 0 1 2, this is exclusive. This will be exclusive, yes, correct. And right, so we have segregated it out. Now what we have to do is that okay, we can do one thing. Suppose we have two arrays, one is -2 comma -1 and the other is 4 comma 5. We can put one pointer here and the other pointer here, and okay, and then I can square it over here and see which one is larger, and the one which one is the one which one is actually which one is smaller, and the one which one is smaller, I'll add it to an array and increase its index, and the earlier one will be there, and we'll do the same thing here. Yes, so let's give a comma b. Okay, so we have to check while a is less than length of neck and no. So we'll if I do this condition, Okay, so if there is any remaining uh, things in the array, in any of the array after that, it means it will be larger, obviously. So we'll just add it at the square to the end. Enough positive. What we can do is that a give it equals to. So now what you can do is that if it's like that, you can raise that. You can depend neg of a whole square. Alright. Okay, and then we'll just increment it to 1. This way we can merge it out, and in the end, if just check one thing. Okay. If neg or pause, what we'll do is that so if we have any values there, we'll just uh, this will be a poorly written code, but it will be this O to the power O of n solution. so we have to manage it. So for I in neg, just I want to see in numpy if we add it we broadcast it, but here I need to check one more thing. Okay, let's check it out once how this works. We are getting wrong answers here. One issue I've seen it. It's so we have also before appending it we also have to pop just wait a second guys, had a call. Okay guys, I was on a call. So it's still not reversing it, right? Okay, I should reverse it out. I'll just try to solve one after other. This one. I am doing some mistake here as I think it's not okay, so I think you guys have noticed I'm continuing the loop even though I have got the index, so because even it will basically return the last index, so nothing will change here. So break. Far better, yes. We're just not getting the last portion here. So basically here we will do while I will do is that res dot extend I think something will be wrong here, but let me check. I think I will put here range. And not need this for that. I think let me try this. I think you guys understand what I'm trying to do. I'm just trying to the remaining portions I want to add it to the result. So if I keep p if we do this less than I'm basically starting from the root. So and if I remove elements from negative and positive in this step, basically we this will be wrong, this thing will be wrong. So I'm thinking what to do, or we can, okay, okay, let me try and use this a and b only, because I think they are in the position where we left earlier. Okay, shit. Okay, got it. Submit and see. There's issue in some places. So if all is negative, mm, we can do this. Nums it's less than 0, we can return x square for x in nums reversed. What's the issue now? Right. Okay, done. Oh, so as you can see, the easy solution took a lot of my time and effort. Basically, I came at a situation where I was too desperate in solving. So you can see this one was marked as easy, but this portion is actually not that easy, but maybe it's easy. And the early one that I solved, this one, let it load. Yeah, this is medium, but I solved it very easily. So yes, it depends which one you solve and what is your level. So in my level, this solution was tougher. So okay, I'll again come back with new solutions, with new questions. For now, that's it. Bye.